U.S. Army awards Lockheed Martin $3 billion GMLRS deal to expand HIMARS and M270 rocket stockpiles. Lockheed Martin has secured a $3 billion FY26 U.S. Army contract to produce standard-range and extended-range GMLRS rockets, an award reported on June 29 and 30, 2026, that will keep precision fires flowing to HIMARS and M270-series launchers. The deal strengthens the Army's ability to sustain accurate strikes against command posts, artillery batteries, logistics hubs, air defense systems, and other targets beyond the reach of tube artillery. The award reinforces the production of the 227mm all-weather surface-to-surface rocket at a time when GMLRS availability has become central to long-range fires planning. Heavy use in Ukraine and rising Allied demand in Europe and the Indo-Pacific have turned rocket stockpiles and industrial capacity into key factors for deterrence, readiness, and future high-intensity warfare. GMLRS is not a single munition but a family of guided rockets packaged in the same launch pod architecture used by HIMARS and MLRS units. A HIMARS launcher carries one 6-rocket pod, while an M270 family tracked launcher carries 2 pods, giving a battery commander either high mobility and easier air transportability or greater salvo density from an armored launcher. The basic rocket uses inertial navigation aided by GPS and flight control surfaces to correct its trajectory after launch, which separates GMLRS from older unguided MLRS ammunition whose effects depended on massed area saturation. For Army planners, that distinction is central. A 6-round HIMARS pod is not simply a larger artillery salvo, but a set of individually guided shots that can be assigned against separate aim points when target quality and command control timelines allow. EZOIC. The standard GMLRS combat load is built around 2 principal warhead types. The M31 series unitary rocket carries a 200-pound class high-explosive warhead intended for point targets such as command posts, ammunition storage sites, bridges, radar vehicles, hardened firing positions, and buildings. The value of the unitary round is target discrimination. When coordinates are reliable, it gives a brigade or division fire cell a way to strike a single military object without the dispersion pattern of older cluster rockets. The M30A1A2 alternative warhead addresses a different problem. It is designed for area targets or imprecisely located targets without using submunitions, and the Army's Operational Test Authority described the warhead as a 200-pound high-explosive assembly containing roughly 160,000 preformed tungsten fragments. Its intended target set includes counterfire targets, air defenses, command posts, assembly areas, light material, and other high-payoff targets. The alternative warhead is operationally important because it replaces the function of dual-purpose improved conventional munitions rockets while avoiding the unexploded submunition hazard associated with older cluster ammunition. In a 2017 U.S. Army Central account, officers described the M30A1 as using about 180,000 tungsten steel balls and noted its usefulness against personnel and light-skinned vehicles. Operational test documentation used a more conservative figure of approximately 160,000 preformed tungsten fragments. The difference in public figures reflects reporting and configuration descriptions rather than a change in the tactical role. The warhead is intended to produce wide-area fragmentation effects against soft targets, artillery positions, parked vehicles, and exposed equipment without relying on hundreds of small bomblets. Accuracy data from U.S. testing gives a clearer picture of why GMLRS has become central to Army fires. During FY14 qualification and developmental operational testing of the alternative warhead, U.S. test reporting recorded 17 successes in 17 production qualification flights, with a median miss distance of 2.1 meters, followed by 15 successes in 15 flights during soldier-conducted tactical fire missions, with a median miss distance of 2.7 meters. The same reporting noted a contractor specification of less than 15 meters circular error probable and recorded that one of the tactical fire missions was completed under GPS jamming conditions. These figures should not be read as a guarantee of wartime accuracy in every electronic warfare environment, but they explain why GMLRS allows fewer rounds per target than unguided rockets and reduces launcher exposure time after firing. EZOIC. Extended-Range GMLRS is the most significant capability change inside the new award. Lockheed Martin stated in December 2025 that an GMLRS alternative warhead variant was fired from a HIMARS launcher to 112 kilometers at White Sands Missile Range, New Mexico, and that the configuration is designed to reach 150 kilometers, more than twice the 70-kilometer range associated with standard GMLRS. The military effect is straightforward. Launchers can remain farther from counter-battery threats while still reaching targets previously requiring ATACMS, PRSM, aviation, or joint fires. GMLRS also fills a range band between standard rockets and the precision strike missile, which helps commanders reserve more expensive deep strike missiles for targets that require greater reach or different terminal effects. The production side is also measurable. The FY26 Army Missile Procurement Justification Book shows that FY2025 GMLRS procurement covered 5,448 rockets at about $938.9 million, including 2,970 standard-range unitary rockets, 1,968 standard-range alternative warhead rockets, and 510 extended-range unitary rockets. The same document states that the Army established separate FY2026 funding for each GMLRS and GMLRS variant and requested $43.156 million in advance procurement to buy long lead items and reduce standard and extended range production lead time from 36 months to 24 months. Those long lead items include insensitive munition propulsion system motor components, guidance sets, payload electronics, and control actuation system items. Lockheed Martin stated production measures expanding final assembly and integration capacity, increasing automation in inspection and test operations, qualifying additional suppliers for critical components, growing the workforce, and modernizing tooling and digital manufacturing should be viewed as part of the same problem the Army budget documents identify. Lead time, not only annual funding, determines how quickly munitions inventories can be rebuilt. For Congress and allied customers, the key question is therefore not whether GMLRS is tactically useful, that is already established by its range, accuracy, and launcher compatibility. The question is whether the industrial base can produce enough rockets, with enough guidance and propulsion components, to support training, war reserve stocks, foreign military sales, and sustained combat expenditure at the same time. Operationally, the $3 billion award gives the U.S. Army more depth in the munition most closely tied to brigade and division precision fires. Standard GMLRS provides accurate attack options at tactical depth. Alternative warhead rounds give commanders an area effects choice without submunitions, and GMLRS extends the reach of existing HIMARS and M270-A2 units without requiring a new launcher fleet. In a high-intensity conflict, that combination affects not only lethality but tempo. The force that can locate targets, assign fires, reload, displace, and repeat the cycle with available guided rockets will place more pressure on enemy artillery, logistics, and command networks than a force constrained by small precision munition stocks.